You wake up and for 1 second, you're still half inside it. A strange version of your old school, a conversation with someone who died years ago. Flying or falling or being chased by something you can't quite picture anymore. And then, by the time you're sitting up, reaching for your phone, it's already disappearing. Not slowly, almost instantly. Within a few minutes, most of it is just gone, and you're left holding a vague feeling instead of an actual memory. Here's the strange part. Scientists estimate that people forget somewhere around 90% of their dreams within minutes of waking up. That's not a small memory glitch. That's almost everything gone, every single night for your entire life. So why does a brain that's perfectly capable of remembering complicated, emotional, vivid experiences during the day completely fail to hold on to the exact same kind of experience at night? To understand why dreams disappear, you first need to understand what's actually happening in your brain while you're having one. Most vivid dreaming happens during REM sleep, rapid eye movement sleep, a stage where your brain is almost as electrically active as when you're fully awake. But active doesn't mean all regions are equally switched on. Dream researcher Deirdre Barrett at Harvard Medical School has pointed out that during REM sleep, the brain regions responsible for transferring short-term experiences into long-term storage, along with the long-term storage areas themselves, are relatively shut down. In other words, the experience is happening in vivid, full detail, but the system that would normally file it away for later isn't running. It's a bit like a security camera recording a brilliant, detailed video, while the hard drive meant to save that footage is unplugged the entire time. There's a specific chemical reason behind that conveyor belt jamming. During the day, your brain relies heavily on a chemical called norepinephrine to help stabilize and encode new memories as they happen. During REM sleep specifically, norepinephrine production drops dramatically, almost to nothing. Researchers studying the neurochemistry of dreaming have found that this near-total absence of norepinephrine during REM is one of the strongest known reasons dream content fails to get locked into memory the way waking experiences do. Without that chemical signal present, the brain can generate an experience just fine. It simply doesn't have the right conditions to preserve it once you wake up and that chemical balance shifts back. This next part flips the whole question on its head. For a long time, scientists assumed dream forgetting was simply a side effect, memory machinery being offline, nothing more. Then researchers at the National Institutes of Health studying mice found something that suggested otherwise. A study published in the journal Science identified a specific set of neurons, originally known for producing an appetite-related hormone, that appeared to actively suppress memory formation during REM sleep. The brain wasn't just failing to save the dream. In this study, it looked like specific cells were doing work to actively erase it. What makes this finding particularly strange is where these neurons were originally discovered. They'd been studied for years almost entirely in the context of hunger and appetite regulation, nowhere near memory research. Finding them moonlighting as an active eraser of dream content was not something researchers were looking for. It came out of experiments designed to understand a completely different system entirely, which is part of why it reshaped how scientists think about forgetting in general. If that holds up across further research, it reframes the entire phenomenon. Forgetting your dreams might not be a passive gap in your memory system. It might be an active process your brain is deliberately running every single night on purpose. And if forgetting can be an active, deliberate brain function rather than just a failure of storage, that raises a bigger question about how much of your daytime forgetting works the exact same way, quietly erasing things on purpose rather than simply losing them. If your brain is actively clearing dream content, the obvious next question is why it would bother. One widely discussed idea among sleep researchers is sometimes called the clean slate hypothesis. The basic idea is this: dreams are often emotionally intense, strange, occasionally upsetting, full of bizarre or threatening scenarios. If all of that got filed away into permanent memory every single night, your waking mind would eventually become cluttered with thousands of disorienting, half-real experiences competing for attention alongside your actual lived memories. Wiping most of it clean by morning may simply be a maintenance system, letting your brain process emotional material overnight without forcing you to carry the side effects of every strange scenario it invented into your actual waking memory. If most dreams get wiped clean by morning, there's an obvious exception almost everyone has lived through: nightmares. Recurring dreams. The one where you're back in school taking a test you never studied for, or being chased by something you can never quite see. These don't fade like ordinary dreams. Some people report the exact same dream returning for years, sometimes decades. Part of the explanation comes back to emotional intensity. Fear and threat responses trigger a much stronger physiological reaction than an ordinary, low-stakes dream, and that heightened emotional charge appears to help some dream content punch through the otherwise weak memory conditions of REM sleep, the same way an intensely frightening waking experience tends to stick with you far longer than an ordinary afternoon. There may also be a deeper reason these specific dreams survive. Researchers studying recurring dream content, including work from psychologist William Domhoff, have proposed that dreams involving being chased, falling, or threatened may function as a kind of rehearsal space, letting the brain practice recognizing and escaping danger without any real-world risk attached. If that's part of the function, it would make sense for the brain to prioritize keeping that content rather than wiping it clean like everything else. So the dreams that haunt you the most might not be a memory malfunction at all. They might be the only category your brain has decided is actually worth the effort of keeping. Here's a piece that explains why some mornings you remember vividly and others you remember nothing at all, even on otherwise similar nights. Sleep researchers tracking participants through the night using sleep monitoring equipment have found that recall success depends heavily on which sleep stage someone is in at the exact moment they wake up. People woken directly out of REM sleep report dream content far more often and in much greater detail than people woken from deeper, non-REM stages. This is part of why an alarm going off at a different time each morning can produce wildly different results. Some mornings you happen to surface right out of a vivid dream. Other mornings you're pulled up from a stage of sleep that never really held on to anything narrative in the first place. So that vivid, strange, detailed world you were just inside of wasn't a glitch in your memory. Your brain's filing system was largely offline the entire time you were experiencing it. The one chemical that normally locks memories into place was almost entirely absent. Specific cells may have been actively working to clear it, and whether you remember anything at all often comes down to the precise sleep stage you happened to be in the second you opened your eyes. You're not bad at remembering your dreams. You're just waking up into a brain that was never planning on keeping them.